send me again because it's if I don't get it, then it's not possible to discuss.
Sir, could you repeat the email address?
Yeah, physicsmania.bd@gmail.com. You see here on the screen it's available. physicsmania.bd. Actually, I don't use the schools one in coaching, okay, or coaching's one with schools one. I make it separate. Everything, the Google Classroom, email, the G Drive, everything is separated. Otherwise, it will be mixed up, right?
Sir, is this one?
Which one?
Sir, could you check the chat box of Zoom?
Zoom. Checkbox.
Yes, sir.
Chatbox.
Yes, sir. Sir, just একটু চেক করে নেন যে এই ইমেল অ্যাড্রেসটাই না।
Chatbox. Again, I have to open it, download it, lots of download. I'm writing physicsmania.bd at gmail.com. Look, this one.
Sir, is it okay?
Look, this one. I sent. You check the chat box. I wrote it. Is it okay?
Yes, sir.
Okay. Then do it. When I get any documents from you, then I upload that one in Google Drive. Your batch is this one, right? O-level batch 4. So here we have till this much. We have worksheet 1, and then we got worksheet 1 edited. This one is edited one, and this one is you gave first. You see the edited one, you wrote something beside it. Then we got test paper 1. That's it. This one.
Sir, did you get it?
Now I'm checking. Is it showing sent?
Yes,
From
sir.
your part? Okay, I'm refreshing it.
Sir, sometimes it takes time a bit.
Maybe If
If
it
one is
is
congested,
if it is sent,
so it's sent from my side.
yeah, if it is shown sent, then normally it happens that we can see it. It's not taking lots of time to receive. Still not. Okay, I'll check again, no problem. Now, what we are saying, this is your documents, and we were, let us start the new topic, okay? Then we'll check again. No problem. So, I gave
Sure,
you
sure.
topic 3 notes on dynamics, right? What's the, it's written here kinematics, but it's dynamics, okay? At the beginning, the learning outcomes are correctly given. Only the heading was given wrongly. It was not corrected. Okay, I will correct it and upload again. No problem. Look, this one, the learning outcomes. Can you read out the learning outcomes?
Yes, sir. State Newton's third law. Describe the effect of balanced and unbalanced forces on a body. Describes the way in which a force may change the motion of a body. Recall and use the equation F is equal to mc square. Is it mc square? Okay, force is equal to mass into acceleration. Explain that fraction is a force. Friction is a force that impedes motion and produce heating. So what is impedes motion?
Impedes means slowing down motion or affecting motion. Okay, continue. Continue.
Discuss the effect of friction on the motion of a vehicle in the context of tire surface, road conditions, including skidding, braking force, braking distance, thinking distance, and stopping distance.
Hmm.
Describe qualitative motion in a circular path due to the constant perpendicular force, including electrostatic force on an electron in an atom and gravitational force on a satellite.
Okay. Then continue. One learning outcome is left. Continue.
Yes, sir. Discuss how ideas of circular motion are related to the motion of a planet in the solar system.
Okay. So in this topic, dynamics, we are having motion. And in kinematics also we have motion. Both of the topics are dealing with the motion of objects. Right? That is similarity between kinematics and dynamics. There is also dissimilarities or difference in between kinematics and dynamics. Okay. Do you understand what I'm saying?
Yes, sir.
Uh,
So why don't you refresh the inbox again? What if it might have been
okay.
when I reload code?
The difference is in dynamics, we are discussing the force while we are describing the motion of the objects. In kinematics, we don't discuss We don't discuss the motion. Yeah, so we don't discuss
Sir,
the
you are lapping, sir.
force. Just wait, huh? Karim, I
Yes,
have
sir.
one direct call. Just wait 1 minute. Hello, Karim. Karim. Hello, Karim.
Yes, sir.
I'm sorry that one direct call came. That's why I have to. This is
No
important call.
problem, sir.
I have to attend the call.
Sir, why
So
don't you check the inbox? It might have came till now. It doesn't
yeah,
take
yeah,
so
yeah.
long.
I got it. I got it. You see, in my
Oh,
mobile I got it. Yeah. So let's continue the discussion with this one. Then we'll go to the worksheet. No problem. So what is the similarity you understood? That is, both kinematics and dynamics are dealing with motion of the object, right?
yes, sir.
And in dynamics, we are getting the force in our discussion, but in kinematics, we don't bring the idea of force. That's the difference. Is it clear?
Yes, sir.
And force The first thing we have to understand that force can change the motion of the object. This one, uh, the the learning outcome C. That's the first thing we have to bring in our mind. That is, force can change the motion of the object. That means we are getting three things over there. It can change the motion of the body in three ways. What are the three ways? Hmm? Karim, what are the three ways? Can you guess or you have the idea?
In what three ways we can apply force?
No, no. How force is affecting the motion of object in three ways.
Okay. Motion of object, it can change the direction, it can stop, or it can make the object accelerate.
Excellent. These three things. Okay. So this one is the first thing about the force and motion. And the second thing we will try to understand, that is balanced force. Balanced forces. If forces are working on the object, more than one forces are working on a single object, then we are having Newton's first law. And if the forces are balanced, that time we are getting the Newton's first law. If we are getting forces are balanced, but forces are coming from different objects, uh, do you understand me what I'm saying? If we have more than one object and we have more than one force, but the forces are balanced, that time it is Newton's third law. Okay. Hello, hello, Karim.
Yes, sir.
You should respond. If you don't respond, then I don't understand you are getting me or not. What I said about balanced forces, did you understand or I have to repeat?
Sir,
Okay,
একটু repeat করলে ভালো হয় sir.
okay. Look, I'm writing here balanced force. Balanced force are related to two laws, Newton's two laws. I'm writing here balanced force. Don't worry, when you need to uh, need to have uh, more explanation, you should tell me, huh? Or you need to revise the or repeat the explanation, you should tell me. Okay, don't worry, don't hesitate. Balance force are related to two laws. One is first law, and another one is third law.
Sir,
Third law.
what about the second?
Okay, second law it will be for unbalanced forces. Okay, when there will be resultant force, that time only we have the second law. This one, we have some force, but in balanced force we don't have any resultant force, and this is unbalanced. This one, unbalanced force. If it is giving any force, resultant force, that is unbalanced, and it is second law. This one is second law. Okay, now you understood this one clearly, that balanced force is related to two laws, first law and third law, right? And unbalanced force is related to second law. This one is clear. Now, what is the difference in between first law and third law? In third law, we are having balance force and we are having two objects. The forces are applying on two objects. Two objects.
Yes, sir.
Yeah. In third law, we are getting two objects. Like you are applying force on the ground, and ground is also applying one opposite and equal force on you. So you are getting two objects. One is you, another one is the ground. Is it clear to you?
Yes, sir.
And first law is related to only one object. Like a parachutist. A parachutist is falling down with terminal velocity. That time, uh, you are getting only one object. The parachutist is only one object, and a force is working downwards, that is weight. A force is working upwards, that is air resistance. One object. Is it clear now?
Yes, sir.
So this one you have to remember. Then all the questions related to first law, second law, and third law, you can answer easily. This is the basic thing. Now, you have idea about Newton's third law. Every action has equal and opposite reaction, and already I gave you one example that with your feet you are stepping on the ground, applying force, and the ground is also giving you an opposite and equal force. That is Newton's third law. And first law, the object can be stationary or the object can be in constant speed. Do you understand what I'm saying?
No, sir. Not this one.
And the first law, I said the object can be stationary or the object can be what?
Accelerating.
No, not accelerating. There is no force, so how can there be acceleration? There is no resultant force. It's balanced force. The object is
Sir,
in
could you explain
const.
explain this one again?
Yeah, I am explaining this one again. You will get more explanation in my notes. Just now I am giving you the brief idea. That is first law. I am giving you one example. Like uh, you are sitting on the chair now, right? Isn't it? Hello?
Yes, sir.
So when you are sitting on the chair, you
I
are
am, sir.
you are stationary, right? You have no resultant force working on you.
Yes, sir.
Your resultant force is zero, your acceleration is zero. So that is Newton's first law. Again, we can have Newton's first law.
But sir, it also said that uh, what was it? Yeah, it moves in a straight line.
Yeah, that part I am now saying. That part I am now explaining.
That
When
every object
when
move in a
when the
straight
object
line.
is in motion, let me say when it is in a straight line motion. When the object is in motion, like the object is going with constant speed on a road, right? Like a car. A car is moving with constant speed on road. That time we have two forces working. One is driving force or forward force coming from the car engine. Okay, and another one is coming, that is opposite force. Opposite force of
Sir, এটা other হবে না because air resistance কাজ করে, তারপরে friction কাজ করে, gravity কাজ করে.
yes, yes, yes. So all we are explaining now, we are saying it's moving forward on a straight line, the one you are saying, right? Isn't
Yes,
it?
sir.
So it's moving forward in a straight line. In that condition, if your forward force, the driving force from the car, if it is, for example, it is 100 Newton, and the friction coming from the road surface and tire, uh, as well as the air resistance coming, if you sum up, it is also the same as driving force, then you don't have any resultant force, right? Isn't it?
Uh, I didn't understand, sir.
I'm saying the driving force, for example, it is 100 Newton. Okay, and driving force, you have one car like this. Here is the car. Okay, here is the car, and you have the driving force in this direction, and the resistance from tire surface and the air resistance are coming in this direction, right? Here it's getting 100 Newton, and the sum of air resistance and the frictional force also 100 Newton. So what is your resultant force?
0.
Zero. If you don't have any resultant force, then your acceleration is also zero, right?
Yes, sir.
But the object is in motion. The car is in motion.
Yes, sir.
That time we are having this graph, speed time graph, VT. That one is giving you one straight line like this, okay? It's constant speed, isn't it? As your acceleration is zero means there is no change in speed, right? There is no change in velocity. Are you clear?
Yes, sir. It's been clear.
Okay, so in Newton's first law, we are dealing with the object which is stationary, also the object which is at constant speed in a straight line in linear motion. Okay,
Yes, sir.
so Newton's first law also you got some information. We will have more discussion, no problem. We have all the things here explained. I just give you now brief, okay, so that you can track with the all notes. Okay, so all these things we have also in recording. When you think that you need to have them revision, you can go through, no problem. Now we are having the learning outcomes E, that is explain that friction is a force that impedes motion and produces heating. This one is very clear to you, right? By friction, any object is getting, slower, right? Isn't it, Karim?
Yes, sir.
By uh, applying friction, the objects are getting slower, right? Any
Yes, sir.
object. So when they are getting slower due to the friction between surfaces, they also produce heating, right?
Yes, sir.
Temperature increases between the surfaces.
Yes,
If
sir.
you if you rub your hand, both the hands, you will also get heating, right? Due to
Because
friction.
energy is releasing.
Uh, Due to friction, right?
Yes, sir.
Okay. So I think this one is also clear to you. Now we are having the friction of a motion that's related to tire surface, road conditions, and then we will have the discussion of braking force, braking distance, thinking distance, and stopping distance. You know that tire surface, if the tire is new, then it has a good grip, right? To stop the
Yes,
car
sir.
easily. Uh, and if it is old tire, then sometimes it becomes
Grips are
slippery, right?
worn out and the surface is smooth.
Yeah. Then we have, wait please, huh? 2 minutes.
Farazan.
Okay, Karim, what we are saying about the tire surface. Hello, Karim. Karim,
Yes, sir.
what we were saying about tire surface, that's also similar about the road conditions, right? If the
Yes,
road
sir.
is wet and if the road is very much, slippery for any reasons, there can be, mud, there can be water, or for any reasons it's slippery. That time also it's affecting the braking distance, right?
Yes, sir.
So when, for example, you are driving a car, right? You
Sir,
are
I don't know how to drive.
yeah, you are driving a car. Then in front of you, you are seeing something, you know, that you need to stop the car now, right? So when you see the, uh, you know, the obstacles or anything in front of you, you cannot you press your brake then and there. Maybe it will take 2 or 3 seconds, right? Or maybe it will take 1 second, fraction of second at least, right? To react, to apply the brake, isn't it, Karim? Hello, Karim.
Oh, yes, sir, I'm here. I mistakenly muted my mic.
Yeah, you understand what I'm saying.
Yes, sir.
So if you need some time to press the brake, by the car is already in motion, right? For example, it is in motion of uh, 5 meter per second. So if it is taking 1 second to press the brake, then it will go 5 meter forward, right? By thinking only or by reacting only. When you
Yes,
are
sir.
reacting to apply the brake, already you passed 1 second. That means already you went forward 5 meter, right?
Yes, sir.
So that one is called thinking distance. That one is called what?
Thinking
Thinking distance.
distance.
And after applying brake, the car slows down, and before you know, before it becomes stopped, completely stopped, it goes some distance. It is, isn't it? If you,
Yes, sir.
if your car has some speed, if you brake the car, then and there it will not stop. Maybe it will take 3 seconds, right? It will take 3 seconds, and you have some deceleration, and because of this time, you will have some distance moved, right?
Yes, sir.
And that is called braking distance. The
The
force you are,
actual distance of braking.
sorry,
The actual distance in which the car actually braked,
yes,
I
yes,
mean
after
slowed
brake,
down and stopped.
after the brake is pressed, then the distance you traveled before stopping the car, that is called braking distance. So
or uh,
this
or
this
in terms we could just say that, because in O level we can't just say that after pressing the brake pedal. So can we just say it like after the car start decelerating till it stops?
Yeah, we can say that one also. Decelerating. I told you to pronounce decelerating, not deaccelerating. Huh?
Sir, this
Decelerating.
time I just say decelerating.
Decelerating or slowing down, you can say, or you can say retarding. Okay, this way you say. Now, these two distance together, braking distance and thinking distance, if you add them up, if you sum up them, that's making your stopping distance. Okay,
Okay, sir.
so stopping distance is the sum of braking distance and thinking distance. Is it clear?
Yes, sir.
Okay, so till here we are done today. Another thing is left here, that is circular motion. Okay, circular motion. When we are getting circular motion, the
Sir, this
satellites.
was just the introductory part, isn't it?
Sorry,
This was just the introductory introduction part, isn't it? Or it's the whole chapter?
the whole chapter. This one is the whole chapter. The one I'm discussing. Whatever is discussed now, those things are written down. Okay, so we did till here. F. Till F we did the learning outcomes. Now we are
Okay, sir.
doing this one, the circular motion. This G and H together we will do now. Okay, what happens in circular motion? If you take one string and stone like this, this way we can do. You are whirling the stone. You are getting a circular path,
What's a
right?
whirling? So
Whirling,
what does the whirling word means?
whirling means you are moving, like you are fixing the string in your finger. Then you are moving it
Oh,
in
I understand,
circular
sir.
path. Moving the stone in circular path. That's that's called whirling. Okay, so you are getting one circular motion like that, right? There is a circle here, though my circle is not that's correct, but it's understandable, right? So here you have the string and here is this
Sir,
stone.
let me draw it for you.
Yeah, no problem. You just understand. Look, here is the uh, direction of
Force
the
acting.
velocity of the stone. When the stone is in this position, then again the stone is coming in this
Sir,
position.
isn't it called centripetal force?
Yeah, we are going there. We are going there. And when it is coming to this position, the direction of velocity is like that. Okay, this way it will continue. When the stone is here, then the direction is in this direction. And how we understand it clearly, that when somehow if the string is detached from the stone, or you are just leaving the string from your finger, then you will see that the when you are just leaving the stone's position, you will see it will go straight in that direction, right?
Yes,
Can
sir.
you guess this one? So from that one, we can understand the velocity direction of the stone. So this one we are getting here. We are getting always constant velocity. The magnitude of the velocity is constant, but the velocity is changing the direction. That's why we are saying the object is at constant speed. Is it clear to you? As the velocity is changing the direction, we are saying it constant speed. The stone is moving with constant speed in a circular path. And there is another point you have to remember, that is this one. We are having acceleration. The one you are saying centripetal, it is centripetal acceleration. Why we are getting acceleration? We are saying
Sir,
this
isn't
is
the acceleration arrow in the wrong path?
no acceleration is working in the uh, acceleration is
It
working,
works towards the center of the.
yeah, towards the center of the circle, as it is circular path. Now my point,
Or
what
sir,
I
can we
wanted,
say that it accelerates towards the force,
yes, we are going
the
to that
origin
one.
of the force?
We are going to that one. Let me explain how we get the acceleration. Uh, this one shouldn't have acceleration as we have constant speed, right? In our uh, first law explanation, you understood that if the object is moving in linear motion, in a straight line with constant speed or constant velocity, there is no acceleration, right? Can you recall that one? If the velocity is constant or speed is constant, there is no acceleration you got, right?
Yes, sir.
But here we get acceleration. Why?
Because a force is acting on them.
No, not for that. Not for that. We are getting force
Sir,
from
your sound
acceleration.
is coming very vivid. Could you take the microphone towards your mouth?
Yeah, now it's okay.
Yes, sir.
Okay, so why we are getting acceleration? Uh, though we are not getting different velocities or change in velocity, however, we are getting acceleration. Why?
It's a really difficult question.
Very difficult question, but it's uh, not that difficult. Only we have to add another idea with that one, the one we got before.
A force is acting on them, and it is stick to one point. Means
Yeah,
it is
we
tied
told
with one point, so it
we
doesn't have any other route to move.
yeah look, we said that we are getting force as we are getting the acceleration. If we don't have any acceleration, we don't have any force. So we have to go with the
বুঝলাম না স্যার
we have the formula of force. Resultant force is this one, right? F equals ma, right?
Yes, sir.
So if you don't have any acceleration, you will not have any force. Got it?
Yes, sir.
So we have to first understand why there is acceleration. Then if there is acceleration, the force will come automatically. Now we have to understand why there is acceleration. The acceleration is because of one property of the objects. If the object is in circular motion and is changing the direction of velocity constantly, then there will be acceleration towards the center of circle. In linear motion, we got this was linear motion. We got no no acceleration, no acceleration for constant speed or constant velocity, right? We are getting there acceleration if velocity changes, right? Velocity increases in linear motion, right? Hello, Karim.
Yes, sir.
If we have velocity increases, then we have acceleration only increases. If we have increase in velocity, then we have
Means
acceleration.
velocity is directly constant. What
So
was that? Proportional to acceleration.
yeah, velocity change. But in circular motion, if you don't have even velocity increase or decrease, but we have direction change. We have direction change here, right? Velocity is changing the direction.
Yes, sir.
That's why, because of this changing in direction, in linear motion, we are not getting change in direction, but in circular motion, we are getting constant changing in direction. And because of this changing in direction constantly, we are getting one acceleration towards the center. Got it? From where we are getting acceleration?
Yes, sir.
In linear motion, we are getting acceleration due to change in magnitude of velocity. And in circular motion, we are getting acceleration due to change of direction of velocity. So is it clear? Is it
Yes, sir.
clear now? So as we are getting here acceleration towards the center of the circle, we also have the mass of this stone, right? Isn't it?
Yes,
Hello?
sir.
So if it has mass, So we can use this formula to get the force, resultant force, and that force is working towards the center of the circle also. We are saying this resultant force as centripetal force. So these kinds of motions, the circular motion we are getting in planetary system, we are saying solar system, our solar system, or any solar system, all the stars, they might have some planets around them, and they have also solar system, and all the planets are moving around the sun or stars. They are also having this circular motion. Again, we have circular motion for electrons moving around the nucleus. We have circular motion when the car bends, uh, you know, curve path. Sometimes the car has to go right or left, and they have some speed that time. They have some velocity that time. That time, for a while, they are going in curve path. They are also having the circular motion. So, is it clear to you?
Yes, sir.
So that's all about this topic. All these things are explained in this theory part. I suggest you to go through this one again.
Sure,
Okay,
sir.
you go
And
through
if I
again
have
and
any
try the
doubt, I will
worksheet.
sure ask you in the next.
Yeah, you try the worksheet I uploaded, please, and we will discuss both the worksheet 2 and 3 together in the next class, inshallah. Okay, is it
Okay,
clear?
sir.
Yeah, our next class will be after 1 week. We have 1 week holiday for Idul Azha.
Ah, sir.
Is it clear to you?
So,
Or you want to continue class during the vacation? Tell me, Karim. If you want, then I will try to manage, because night
yes,
time
sir.
I don't have any other works. I can continue for you.
Actually, I have another class, sir.
Mm-hmm.
I have another class.
I am not saying about today. I am saying the vacation time.
It's okay, sir.
If we have 1 week break, is it fine for you, or you need
Sir, it would
less?
be better. And
Is it fine?
so it would be better if the time increases.
No, 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 no. No.
Please, sir, for a short
Look,
period of time.
listen. We have next class when, according to our routine, it will be on
On
10th.
the of 9th of August.
No, no, not 9th of August. 9th of August is Sunday. We will
Yes,
have
sir.
on we will have on 10th of August.
Oh, okay, sir.
Is it fine?
Thank you, sir.
Because our routine, according to our routine, it is on 10th of August. We are having only
Yes, sir.
1 week holiday, okay, for you and all the students of my physics mania. Okay, thank you so much. And now I am stopping the recording. Uh, okay, but I want to